Alright, that's what we're going to do for square root functions. Now we're going to look at cube root functions. And by the way, I haven't mentioned, I know a lot of you probably have graphing calculators, and I don't care if you use it to check what you're doing, but of course on the assignment and on the test I'm going to be looking for these steps that I'm illustrating to make these graphs, okay? So if we look first at the parent function of the cube root, again, the parent function just means that we don't have any shifts. The domain for this one, with the square root, we got into trouble because we can't take the square root of a negative. But remember from what we've learned in this chapter that we can take the cube root of a negative, right? So the domain for any cube root function is actually going to be all real numbers. So that really means you could pick absolutely any real number that you wanted for x. But just like with the square root graph, we can choose numbers that will make our life simpler because they work nice. And since we're going to be taking the cube root of the value that we use, we want to choose values that are perfect cubes. Now, not only do we want them to be perfect cubes, but we need them to be able to contain within this little 10 by 10 graph, right? So the set of perfect cubes that I'm going to choose is -8, -1, 0, 1, and 8. So this is 0 cubed, 1 cubed, and 2 cubed, -1 cubed, and -3 cubed. So these 3 points right here, when we graph, you're going to see that they're going to define the center curve of the graph. And then by having one more on each end, we can get a good approximation of how quickly or slowly the graph is going to widen, okay? So again, I'm going to use y equals cube root of x in the middle and then have the ordered pair over here. So if I plug in my x value, the first one, if x is -8, the cube root of -8 is -2. And if I plug in -1, the cube root of -1 is -1. If I plug in 0, the cube root, the cube root of 0 is 0. If I plug in 1, the cube root of 1 is 1. And last, if I plug in 8, the cube root of 8 is 2. So if we graph these, I have -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So this is what I was talking about. You see those 3 points, -1, 0, and 1, are going to give me the curvature in the middle. This one has all real numbers, so we have arrows on both ends. So I'm going to combine my points with a line that extends forever in both directions. So when we do a cube root graph, we do want to have 5 points. We always want the 3 that define that section in the middle, and then 1 further out on each end. Okay? All right, now we have to go through all the shifts for this one too. So again, if the change is under the radical, it's going to be a left or right shift. So if we have f of x equals cube root of x minus 2. We need to figure out what values of x to choose again. And just like with the square root graph when we did the left-right shift, we're not going to be able to just choose that set of perfect cubes that we used, because the changes underneath, we need to determine what will actually give me those numbers. So I usually make the list of the perfect cubes that I would normally use. So this time, probably the easiest thing to do is just the same thing we did with the square root. Take what's under your cube root and set it equal to 0. Basically what that's doing is telling you the shift, right? That's how much the graph shifted. So if I add 2 to each one of the perfect cubes we would have used, then I should get a perfect cube under my root. So let's see if that works. So negative 8 plus 2 would give me negative 6. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. And 8 plus 2 is 10. So let's see if it worked. If I substitute negative 6, look what happens. Negative 6 minus 2 is negative 8. And I know the cube root of negative 8 is negative 2. So that worked. Alright? So then we just have to do that for each one. This gives me the cube root of negative 1 is negative 1. If I substitute 2, we get the cube root of 0 is 0. If I substitute 3, I get the cube root of 1 is 1. And last, if I substitute 10, I get the cube root of 8, which is 2. Alright, so we have negative 6, negative 2, 1, negative 1, 2, 0, 3, 1. We got those 3 points right there together is what we were looking for, and 10, 2. So then again, we're just going to connect those points with arrows in both directions. Okay? Alright, so we're going to do the same thing for this one. If I take what's underneath my root, this time the shift is going to be subtracting 2. So my usual list, if I subtract 2 from each one, negative 8 minus 2 is negative 10. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. And 8 minus 2 is 6. So that should give me a nice perfect cube underneath. If I substitute negative 10, we do get the cube root of negative 8, which we know is negative 2. If I substitute negative 3, I get the cube root of negative 1 is negative 1. I'm really bad about not leaving myself enough space. This one was negative 2. That gives me the cube root of 0, which is 0. Then we had 1 minus 2 is negative 1. So we get negative 1, 1. And the last one was 8 minus 2 is 6, right? So we get cube root of 6 plus 2 is cube root of 8, which is 2. And now we can graph the points. We have negative 10, negative 2, negative 3, negative 1, negative 2, 0, negative 1, 1, and 6, 2. Then we're just going to combine them again. All right. All right, so with the cube root as well as the square root, if the change takes place outside the radical, it's going to be up or down. And also, like with the square root, when it's an up or down shift, choosing my x's is easier because the only thing that is under the root again is the x. So we can go back to just choosing our set of perfect cubes and plugging them in. So the cube root of negative 8 is negative 2, plus 3 is 1. So we get negative 8, 1. The cube root of negative 1 is negative 1 plus 3 is 2. The cube root of 0 is 0 plus 3 is 3. The cube root of 1 is 1 plus 3 is 4. And last, if we put in cube root of 8, that is 2 plus 3 is 5, and we get 8, 5. Alright, so we got negative 8, 1, negative 1, 2, 0, 3, 1, 4, and 8, 5. Then we're just going to connect them again. Alright, one more of these. We can still just choose our normal perfect cube values because only the x is under the root. So this time we get negative 2 minus 3. So we get negative 8, negative 5. This one is negative 1 minus 3 is negative 4. Zero minus 3 is negative 3. One minus 3 is negative 2. And then last, if we put in 8, we get 2 minus 3 is negative 1. And then if we graph, we got negative 8, negative 5, negative 1, negative 4, 0, negative 3, 1, negative 2, and 8, negative 1. And then we just combine them again. All right. The last thing we're going to look at is graphing circles, and this is kind of one of my favorites. A circle is the set of all points in the plane that are a fixed distance from a given point. That fixed distance is what we call the radius, and the given point is the center. So the standard equation of a circle of radius r and center hk, those are just numbers, is x minus h squared plus y minus k squared equals r squared. So if you look at the first example, you notice from that standard equation, the x and the y are the only variables, right? So what we need in order to graph the circle is the center and the radius. And the center is going to come from these two expressions here. If you take the x minus 2 and set it equal to 0, we get x equals 2. And if you take the y plus 1 and set it equal to 0, I get y is equal to negative 1. So my center is, ordered pairs are x, y, right? So it's 2, negative 1. So that's all you have to do to find the center. And then this number from the formula is the radius squared. So if I want the radius, I just need to take the square root of that number, which is 3. Alright, so we're going to graph the center. It's at 2, negative 1. And then all we need to do is use the fact that my radius is 3 to find points to make the circle. So from the center, I'm going to count 3, because the radius is 3, to the right. 1, 2, 3. From the center, I'm going to count 3 up. From the center, I'm going to count 3 left. And from the center, I'm going to count 3 down. And then all we have to do is connect those 4 points. And that's my circle. Alright? So just to do one more, I've got x plus 3. I'll set that equal to 0. So I get x is negative 3. Oh, well look, we got y squared. So this is the same thing as that. If there's not a number there, it just means that there isn't a shift. So you can just say y equals to 0. So my center is at negative 3, 0. My radius is the square root of 25, which is 5. So I'm going to graph the center. And then we're going to count 5 to the right from the center. 1, 2, 3, 4, 5. 5 up from the center. 2, 3, 4, 5. 5 to the left. 1, 2, 3, 4, 5. And 5 down. 1, 2, 3, 4, 5. And then we're just going to connect those points. And that's my circle.